Right, hello, this is my first video that is education related, like school related and stuff, and sorry about the shakiness of the stand, and it is related to calculating the area of shapes. So, let me make an example here. If I had a shape that was 3... oh dear. We'll go 5. So if I have a rectangle here, one side is 3 centimeters and the other side is 5 centimeters. Sorry, that 3 looks bad. Then the way that I would calculate area is length times width. So in the length being 5 in this scenario, and the width being 3. And that would be 15. Now we do centimeters squared. Pretty cool. So it's 15 centimeters squared, and you want to square it, the units at the end, to make sure your answer is correct. However, that's for rectangles. If we then had a triangle, which I will quickly sketch up here. Now this is a right angle. Oh, where's my ruler gone? Now this is a right angle. Oh, I don't like that. This is a right angle triangle. I don't know why it's not perfectly lining up, but yeah, it's fine. This will be a minute. I'll probably just cut to when it's done. Oh dear. Yeah, I'll just cut. So we have a triangle here, and because it's a right angle triangle, the way you would go about calculating the area of it would be, so we'll say that this is 3 centimeters and this is 3 oh, that's not a 3. 3 centimeters, and then we'll say 4 centimeters. Keep it simple. But this is actually irrelevant. You don't need that at all. What you need to do is base times perpendicular. I can't spell perpendicular. What you want to do is base times height, but you want it to be perpendicular height. And so the base in this scenario would be 3 centimeters times 3 centimeters, because perpendicular is at a right angle, as usually like made clear by the little square, and that'll give us 9 centimeters squared. But that's just like a polygon, a like quadrilateral. So you then want to go and half it, which will actually not give us 9 centimeters, but 4.5. I'll write that down here. 4.5 centimeters squared. So when calculating the area of a standard quadrilateral, it's base times height, or length times width, take how you want. But when calculating the area of a triangle, it's base times height over 2. So because you need to half it afterwards. So yeah, pretty cool. Now, if you have a circle, here. Let me put this in perfectly. No, let me put this in so it's like right. So we'll say that this is a perfectly fine circle, and the diameter, which is the point that runs from A to B, is 6 centimeters long. What you want to do to calculate this circle's area is do... How should I phrase this? So you want to find the radius, which is half of the diameter. So the radius is actually that's right angle. So not that it matters, but you want to go from the center usually. So you want to do pi, which is like the amount of diameters that fit in the circumference or the outside of a circle. And you want to multiply that by the radius, which in this scenario is 3 centimeters. And you want to have that squared. Actually, no, my bad. I should write this as an equation. What's the equation of? Yeah. So you want to do pi, which is basically 3.14. Multiply that by 3 squared. Multiply that by 9, and that should give us... I'll be back in a minute. So I'm back. So I have a scientific calculator with me this time. What you want to do is do pi, so that's shift is up here, and then you can see a little pi, and you want to do times 9, because that's squared, and that will give us 9 pi, but that, and then you want to hit the SM button to get it to this, and if we round to 2 decimal places, that should give us 28.27 centimeters squared, which is the area of the circle. Now there is another way to calculate the area of a triangle, which I shall show you quickly. So I'll just quickly mop up a triangle. So there's a more complex way to calculate the area of a triangle, which will come in useful probably in my next video, which will be calculating the area of segments, and that is the equation. I've done this weirdly, sorry, but the equation is half AB sine C. So AC should be a capital. That C looks weird. So in this scenario, our angle, so A and B are the sides. Sorry, I missed out a small detail. So this is an equilateral triangle, and A and B are both 10 centimeters. So you want to multiply on your calculator 10 times 10, which will give us 100, and you want to do answer divided by 2, because we need to half it, and that gives us 50. Now we have to do answer sine, which is right here, and then 60, because 60 is the angle, which is in this scenario C, and that will give us 43.3. And I calculated that using this. And this is especially useful if you don't have access to the perpendicular height, because I don't here. Whereas if we had a right angle triangle, I'd have access to the perpendicular height. So yeah. So that's pretty useful for calculating area of a triangle. So yeah, in this video I covered calculating area of a quadrilateral. That's like, or just square and rectangle. I'll do trapeziums and parallelograms in another video. And triangles. And I also gave you this way to calculate it. This is slightly more advanced, and it comes in useful when dealing with circles. And I also gave you the way to calculate the area of a circle. So, thank you for watching this video, and I'll see you all later. Bye!